All right, I didn't want to make the first video too long, so now let's look at some questions in WAMAP that we can do for some additional examples. So we'll get rid of this, maybe. And here we go. We have some examples. So as we're talking about correlation, in the first one I was trying to make sure that we were using a context that made sense here. So now we just have some values here, we have some values here. We need to describe whether we have a positive linear, negative linear, nonlinear, or no relationship. And so what we're looking to do is trying to see, can we draw a line in here, maybe, this is how I kind of tend to think about it, that sort of shows the trend of the data. And so with this one, it doesn't really seem to have a lot of serious trend to it. And as we do more of these, you might think they get better and better. So if we had a positive relationship, we kind of see a trend in the data that went up in some fashion. It doesn't have to go up really fast. Or if we have a negative relationship, we'd be looking for a trend that goes down. And you can kind of see maybe here a negative relationship, but also maybe here a positive one, which tends to make me think there isn't really a relationship here. So I would think there's not a real relationship here in this one. So that's good. And now as we look at the second question, you can see here what maybe a different one sort of looks like. As we go and try to make a line of this, we can see a line that as these guys decrease, as x increases, y decreases. And so that means we're going to have a negative linear relationship here. Now as we look at this one, we can see a trend now where they're both increasing at the same time, and so this is probably a positive linear. And then here's another scatter plot. And we're looking to decide on this one just whether it's linear or nonlinear. So we could kind of approximate this with a line, so this is going to be linear. Now it says estimate what you think the correlation coefficient could be. And we kind of had a table there that talked about the strength and what those might look like. So I would say if I was drawing a line here, I can see a positive trend here. Now, it's not a super tight positive trend, but things are moving in a positive direction. So 0.9 would be kind of a lot closer to like this, where we have stuff that's pretty linear, maybe not quite that tight or maybe tighter. Anyway, but 0 would be kind of no relationship, and a negative value would be one that's decreasing here. So we're talking about kind of the slope of the regression line, which we'll get to a little bit more in 7.2. So I would think this one's going to be right around 0.6. See, we have here an actual 0.657 from the data. So 6 is kind of something similar here. You have to match these with what's happening in the data over here. And so you can see A is a strong negative, a very strong negative relationship. So we would expect something where we have a tight formation and they're decreasing. So this is going to be A, most likely, unless we have a better one here. Now B is negative 0.21, so that's going to be a negative relationship, but it's going to be really, really weak. And so I would say here's a weak relationship, and here's another weak relationship. This one looks more positive, so maybe B here is the top one with a negative trend. And then C, 0.95, so that's a positive, very strong relationship. It's going to look something like this. So this is letter C. And then D, we have a positive relationship, but it's pretty, it's moderate. So we can see here, but we don't have a tight relationship like we do here, or a strong relationship, excuse me. So this one's going to be D. If we click those here, DADC, good job. Okay. So a similar one here, and kind of have some pictures, again, without a context, but it works for these. And now, bivariate data is just what we call data that's paired as far as x and y axis, so don't get too alarmed with that. So our first one is comparing x and y. The second one compares w and y. Where is that? A V? Looks like w and y. It says which explanatory variable has a stronger relationship with the response variable. And they tell us here, response variable y. So we're looking to see which one of these has a stronger relationship. And so that's going to be, again, is the data clustered tighter together, closer to a line, or looser together? And so to me, this first one looks like it's a little bit tighter than this one. I can't really even tell for sure if this is a positive one. Anyway, so I think the first variable has a stronger relationship. And then again, another one of these where we have a value. This might be a case where we really can't tell, and it's probably like no linear relationship, more like a 0 here. It doesn't seem to be trending up or down there. Okay. So, another one here, 10, it says annual high temperatures in a certain location have been tracked for several years. Let X represent the year and Y the temperature. Based on the data shown, calculate the correlation coefficient to 3 decimal places. And it says use your calculator. You do not need to use your calculator. You are welcome to use your calculator. I'm going to jump over to Excel and show you how to do this. I went through one of these earlier. So, similar here. We have those. Oh, it might be a good idea to paste these special. Let's see if we can work here. Yeah. And sometimes when you paste them, these things copy in that they're not. So if you right click and then paste special, you can find your correlation coefficient better there. So again, the function is correl, and we just grab our X values and then our Y values. And I don't include the variable here. Close it up. And this gives me the correlation coefficient. If you ever need more decimal places, just make the box a little bit larger by grabbing the right-hand side. So this is 0.9944. And we were looking 3 decimal places. So 0.9944. There. You can see it kicks out the whole thing. Now, I want to talk about this one. Question 11 is one of those where we do want to paste special here. Every once in a while, this one gets fouled up more than any other. So on December 17, 2007, baseball writer John Hickey wrote an article for the Seattle PI. You can find it here about increases in ticket price for Seattle Mariner games. The article included data on the set listed the league in which the teams, American League, National League, the number of wins during the 2007 season, and the cost per win in dollars. So the data for the 16 National League teams are shown. Compute the correlation between 2007 price and the number of 2000 wins for the 16 teams. Assume the correlation conditions, round your answer to the nearest, what's that, thousandth? So I'm going to copy this, and again, this is one where I probably need to try to paste special and see if everything comes in correctly. Now, some of these here, it'll ask you for the year. If you get a different context, maybe car, we want to use the age of the car, make sure it's appropriate here. So I can't even remember the question at this point. Compute the correlation between average 2007 price and number of 2007 wins. So price and wins is the correlation I'm going for here. And so again, I'll just use correl, the function, and I'll grab the price. I'll grab the price, comma, and the wins, and close it up, and I get my correlation. So if I had to describe this one in words, since it's really small, this would be, I can't even remember what it was. Very weak. It's between 0 and 0.2. So this is a very weak correlation. Anyway, so I just wanted to do a few more examples. These are the type of questions you might see. 12 has 2 data sets. You'll have to copy and paste them, find out which correlation coefficient is better. And then lastly here, we'll try 13 really quickly because it has something new here. So again, paste. I like to paste special. Those values here. We're looking for the correlation first, so the correl function. This one's nice because we have X and Y and they're labeled. So this is this. And then R squared is the other thing we were asked for. And we literally just take this value here and we square it. So this would be 26.1% when we input it over here. excuse me. So 26.1, and I just wanted to show you that here. I forgot what this number was. I guess I can go back and snag it. We're a little over the time. 0.51117. And so if I go here, 0.511. And so we got those. Anyway, so there's a few more examples for you on section 7.1. Please let me know if you have any questions. I'm here to help and look forward to discussing 7.2.